Good morning, students. Hope you are doing great. This is Dr. Thulasi, working as Associate Professor in the Department of Computer Science and Engineering, Vignans Nirula Institute of Technology and Sciences for Women, Palakaluru. In the last session, we have seen the third unit. The contents of the third unit are Introduction to YAML, Why we model, Conceptual model of the YAML. In the conceptual model of the YAML, we have seen the building blocks of the YAML, rules of the YAML, common mechanisms of the YAML. And next we have seen the architecture. In the architecture, we have seen the 5 views of the YAML. Next we have seen the classes, relationships, common mechanisms, class diagrams and object diagrams. These are the topics which we have covered in the third unit. And in today's session, we are going to discuss about the fourth unit. Coming to the contents of the fourth unit. Today we are going to study about the basic behavioral modeling. And this we are going to discuss about interactions, interaction diagrams, use cases, use case diagrams and activity diagrams. Coming to this session, coming to the next topic, interaction diagrams. Till now we have seen about the interactions. In the interactions we have seen about what is interaction, what is a message and common modeling techniques of interaction, that is to model the flow of control. Next, coming to the interaction diagram, sequence diagrams and collaboration diagrams, which are collectively called interaction diagrams. These two diagrams used in the YAML for modeling the dynamic aspects of the systems. An interaction diagram shows an interaction consisting of a set of objects and their relationships, including the message that may be dispatched among them. A sequence diagram is an interaction diagram that emphasizes the time ordering of messages. A communication diagram is an interaction diagram that emphasizes the structural organization of the objects that send and receive messages. That's what we have seen in the interactions, and here also we discuss about the interaction diagrams only. And interaction diagrams are not only important for modeling the dynamic aspects of the system, but also for constructing executable systems through forward and reverse engineering. The main purpose of interaction diagrams are to capture dynamic behavior of a system. So next, I told you that we are having 9 types of diagrams. In that, 5 diagrams used to represent the dynamic behavior of the systems. And that one of is sequence and collaboration diagram. That those two come under the interaction diagram. To describe the message flow in the system, to describe the structural organization of the objects, to describe interaction among the objects. This is the main purpose of using the interaction diagrams. When you watch a movie projected from the film or broadcast on television, your mind actually plays a trick on you. Instead of seeing continuous motion as you would in live action, you really see a series of static images played back to you fast enough to give the illusion of the continuous image. That is what 24 frames. We have seen all these things in the computer graphics also. And if you see the figure here, it is having 3 objects: client, interaction, ODBC, proxy. So the client want to make a connection with the ODBC proxy, so it automatically creates a transaction. With the transaction, it sets the values of the ODBC proxy. After the completion of the task by the transaction, it kills the transaction object, and next the connection is established between the client and the ODBC proxy. That's what I explained here. This is a sequence diagram. So the messages are passed in a order, okay, in a timely manner. This is nothing but a sequence diagram. Not only this, it is having a object, and below the object we are having dotted line, that is nothing but a lifeline of the object. How much time that object is alive in that particular scenario. So see, if you see the transaction here, once the transaction object completes its task in this scenario, then it is killed by sending a message destroy. That is a cross symbol that indicates the lifeline of the transaction is ended. So for the same sequence diagram, we are automatically generating the collaboration or a communication diagram. If you see the same figure here, we are having some objects. So the objects consist of a message passing between them. So every message, beside the message, we are having a sequence diagram, sequence number that indicates which message is passed first and which message is passed second. So here if you see the links, here we are having a create, set actions, and a destroy. So the message client send a destroy message to the transaction in the third position. So that automatically it is nothing but a transient period. So how much time the object is alive in that particular scenario. Okay, that is a transit object that comes in the middle, and it completes its task, it ends its time period. That is nothing but a transit object. Coming to the common properties of interaction diagrams. An interaction diagram is just a special kind of diagram and shares the same common properties as do all other diagrams, a name and graphical contents that are a projection into the model. What distinguishes an interaction diagram from all other kinds of diagrams is its particular content. What are the contents involved in this interaction diagram? So if you see the contents, interaction diagrams commonly contain roles or objects, communications are links, messages, and node. Node is used to represent the comments. An interaction diagram is basically a projection of the elements found in an interaction. The semantics of an interaction's context, objects and roles, links and connectors, messages and sequencing apply to the interaction diagram. Like all other diagrams, interaction diagrams may contain nodes and constraints also. So to represent the comment, we go for the nodes, and to represent the condition, we go for the constraints. So here in the interaction diagrams, we are having two more diagrams. So which are the forms of the interaction diagram? One is the sequence diagram and second is the collaboration or communication diagram. So first of all, let's see what is a sequence diagram. A sequence diagram emphasizes the time ordering of the messages. You form a sequence diagram by first placing the objects or roles that participate in the interaction at the top of your diagram across the horizontal axis. See here, every sequence diagram will be having two axes, x-axis and y-axis. In the x-axis, you need to place all the objects. In the y-axis, you will be having the lifeline of the object. Typically, you place the object or role that initiates the interaction. Which object initiating the interaction, that is placed on the left side. After that, you place the objects towards the right. And increasingly, more subordinate objects or roles are placed towards the right. Next, you arrange the messages that these objects send and receive along the vertical axis in order of increasing time from the top to bottom. So you need to start the communication at the top, and you need to go down the communication. So at the down part, you'll be having the fresh communication. Okay. So if you see the figure here, it is having three objects. First one is a caller, phone, and recipient. So what the information is passed between the objects. First, caller picks up the phone, receiver. So he'll hear a dial tone. If the dial tone is not here, then he thinks that the phone might be dead. So he can't make any calls. So if you hear the dial tone, then he's ready to dial the number. He'll dial the number, and the recipient will hear a ring sound, and same notification will be heard by the caller also. Even for us also, when making a call, will hear a dial tone. Okay, so that notification will be heard, and after that the recipient picks up the call, then they both will communicate. This is how the sequence diagram is shown. The sequence diagram always shows in the x-axis it shows the objects, in the y-axis will be having the timeline. In the timeline, we are having one thin rectangle, that is nothing but the focus of control. That focus of control indicates how much time the object is active. So if you see the communication, so how much time the object is active, at that time only the thin rectangle is started. If you see the recipient, at the during the pickup and dial tone, it is not active. When the ring sound is sent to the recipient, then only the thin rectangle, that is activation, is active for on the lifeline. So it indicates the focus of control. That is nothing but the activation period of the object. So this gives the reader a clear visual cue to the flow of control over the time. So sequence diagram mainly having two features that distinguish from a communication diagram. I told you that sequence diagram and communication diagram are semantically equivalent and are isomorphic. But these two features make the sequence diagram which is different from communication diagram. What are those features? Let's see one by one. First, there is the lifeline. As I told you, below the object we are having some dotted line, that is nothing but a lifeline. An object lifeline is the vertical dashed line that represents the existence of the object over a period of time. Most objects that appear in an interaction diagram will be in existence for the duration of the interaction. So these objects are all aligned from the top of the diagram with their lifelines drawn from the top of the diagram to the bottom. So all these objects which are in the communication are taken from the left to the right, and down of that objects we are having the lifeline. Objects may be created during the interaction. Then the lifeline starts with the recipient of the object message create. If you send a create, then automatically the object is created. Below that the lifeline is started. So objects may be destroyed during the interaction. Their lifelines end with the recipient of the message destroying. The objects will be destroyed. If you send a message destroy, automatically they will be destroyed. At the lifeline, you can see a cross mark and marking the end of their lives. If the interaction represents the history of the specific individual objects, then object symbols with the underlined names are placed at the head of the lifeline. If you see these are the interaction is between the objects, then you can write a underline between the objects. This is regarding the lifeline. And coming to the second feature of the sequence diagram is focus of control. So if you see the focus of the control is a thin rectangle, tall rectangle. So that shows the period of time during which the object is performing an action, or the time in which the object is active, either directly or through a subordinate procedure. The top of the rectangle is aligned with the start of the action. The bottom is aligned with its completion. And you can also show the nesting of the focus or the focus of the control by recursion. So if there is a recursion, means in that thin rectangle you can draw another rectangle. It means that you can have a stacking of another focus of the control. So that indicates there is a recursion. Okay, this is regarding the focus of the control. If you want to especially precise about where the focus of the control lies, you can also shade the region of the rectangle during which the object's method is actually computing the control has not passed to another object, but this is rather fuzzy. So if you want to actually show that can be drawn by using a gray drawing, but it makes a system to look more fuzzy. So instead of that, avoid that using a shading in the rectangle. So if you see the figure here, we are having different types of objects. Okay, so as we see, these are the in the sequence diagram we'll be having objects placed on the x-axis. Here also we are having objects with the different notations. If you see the first one, student, that indicates only the type, it is a name of the student and the type is not specified here. If you see the another object, that is student, the name is not specified, so it is considered as a anonymous object. If you consider here as a student, it indicates that student is the class and S is the instance of that student. Okay, this is how you can represent the objects in the sequence diagram. Whatever you have represented in the sequence diagram, same will be represented in the collaboration or communication diagram also. As with any UML element, we can add a stereotype to the target. Some often used stereotypes for the objects are actors, boundary, control, entity, databases. These are some of the different types of the objects. Not only the rectangle symbol, you can specify all these objects also. You can specify by a sticky figure, you can specify like an interface symbol, you can specify by using a circle which tells about the direction. You can specify like a book which is an entity. You can also specify the database. These are some of the representations you can use in the sequence diagram. When we want to show how an object interacts with the elements of a collection, we can use a multi-object. Okay, it is basic notation. If you want to tell about the group of the objects, if you want to tell about the collection of the objects, then you can go for the multi-object. So a multi-object means a rectangle inside another rectangle. It tells about the collection of the instances. It might be students, faculty, whatever might be. If you want to tell about object means single instance. If you want to tell about multiple instances, then you can go for this double rectangle symbol. So here sequence diagram, as I already mentioned, it is most common kind of interaction diagram, which focuses on the messages, interaction, interchange between a number of lifelines. Lifeline is a basic concept of the lifeline. Is every lifeline representation an object in existence. Already we have discussed all the things regarding the lifeline. Next, coming to the messages. The message and the element that defines one specific kind of communication between lifeline of and interactions. So usually a message will be between two lifelines. Most cases, and they are categorized according to two broad classes, two major types. One is the action type, and that is what kind of role the message and the message to achieve, and other is the presence of events. Coming to the message by action type. A message reflects either an operation call and a start of execution or a sending reception of a signal. Message by presence of events. A message depends on whether the message sent, event and receive events are present. That the message certainly is something that an object sends to another object in the generic form of a client-server model. We already discussed what is a client-server model. Client always gives a request to the server process the request and gives the information to the client. This is how the information is processed here also. So a message usually will need to have a send event which initiates sending of the message and will lead to have a receive event which is the receiving of the message. So if we classify messages according to the presence or absence of these events, then the classification is called the message by the presence of events. So we go by action type. Then various types of messages under this action type are there. They are synchronous call, asynchronous call, signal, create message, delete message, reply a message. So these are the different kinds of messages that are allowed in a sequence diagram. So these are synchronous call. So let me just explain the basic concept. So there is an object here. There is another interacting object here. And this means something is in execution. Some method of object is in execution. The main content in sequence diagram is the messages. A message is shown by an arrow from one lifeline to another. The arrowhead points to the receiver. The message is asynchronous. The line has a strict arrowhead. If the message is synchronous, the line has a filled triangular arrowhead. That's what we have seen already in the interactions. A synchronous message is used when the sender waits until the receiver has finished processing the message. Only then does the caller continue. So if you see the example here in the figure, sender and receiver, sender sends a message and parameters. So receiver receives the message and processes the message and responds to the and gives a return value to the sender. A closed and filled arrowhead signifies that the message is sent synchronously. So see here, if you see the example, here we are having teacher, web interface, database, wrapper. So if you see here, teacher login by using her credentials. So after that, the database wrapper validate the user. It will give a response, he is a valid user. Then that is the successful validation of the teacher based on his user ID and password. Next, he can look the student information. So till he is validated, next process will not be done in the synchronous communication. So next, after login only, then he can go and look up for the student information. That is what explained in the synchronous. A reply to a synchronous message is shown as a dashed arrow with a stick arrowhead. The written message may be omitted as there is an implicit return after any call, but it is often useful for showing written values. If there is no need of using this written statement, you can omit it. If there are written values, you need to send some written values to the sender, then you can use it. Because too much usage of written values also makes a diagram to look in a fuzzy. Okay. With an asynchronous message, the sender does not wait for the receiver to finish processing the message. It continues immediately. So if you see the figure here, sender and receiver, asynchronous message, they pass the actual parameters. Message sent to the receiver in another process or calls that starts a new thread are examples of asynchronous messages. See here, if you see the customer, waiter and chef. So customer gives comes to the restaurant. So waiter will come and take the order. So he sends the order to the kitchen. The customer will not receive any acknowledgement from the waiter or from the chef. Next, if you see the waiter, he gives the order to the chef and he goes and greets the next customer. There won't be any reply or whether there won't be any message telling that they had done this task. This is nothing but a asynchronous communication. The ordering of time along a single lifeline is significant. Usually, the exact distance does not matter. Lifelines only show relative sequences. So, the lifeline is not a scale diagram of time. Usually, the positions of the message on separate pages of lifelines do not imply any sequencing information. The message could occur in any order. The entire set of messages on separate lifelines forms a partial ordering. So, between the requester and the requested, only one will work at a time. When the requester has sent a request, then the executing this is on hold at this point and only when it has completed. This will start executing again. That is a synchronous. Asynchronous is where the requester sends a request that is initiated. This continues, but the request also keeps on continuing. Requester does not stop. So, requester has to send the task, does not do the task. So, here asynchronous means, so the sender sends the message and waits for the response. In the asynchronous means, the sender sends the message and he won't get any response from the receiver. Still, he starts a new thread of communication. This is nothing but a asynchronous communication. Next one is instantaneous message. Instantaneous, the name itself indicates instant. It means fast. So, coffee also will have instant coffee. So, coming to the filter coffee, it takes so much of time. Instant means within short span of time we can complete it. So, here also same. Instantaneous means messages are often considered to be instantaneous. It means time it takes to arrive at the receiver is negligible. Such messages are drawn as a horizontal arrow. You can represent the instantaneous message with a horizontal arrow. So, next coming to the non-instantaneous message. Sometimes the message takes a considerable amount of time to reach the receiver. For example, a message cross in a network such as non-instantaneous messages are drawn with a slanted arrow. So, that indicates there is a time lag. The sender is taking some more time to reach the receiver. The message is taking more time to reach the receiver. So, here if you see the figure, it is indicated non-instantaneous messages are indicated by using a slanted arrow. Next coming to the complete message. In terms of events, as I said, that most of the messages are complete messages that have a sent event and a receive event. So, when I send a message, this is the point where I am doing the sent. So, I have a sent event like this, and when the message is received by the receiver, I have a received event at this. So, normally a complete message would mean that one that has been sent by the sent event and one that has been received by the receiver. So, because you would expect that why you are doing message, because you want to interact. So, in the interaction, there will have to be sender, then there will be to be a receiver, that is to be received. So, if that is satisfied, then we say we have a complete message. So, this is regarding the complete message. Next, coming to the lost messages. Sometimes, if you send some SMS to a particular person, but it won't reach, it will be lost in the network. Such type of messages are known as a lost messages. So, the lost message is one where you have just the sent. You do not have a receive or found, where you just have the receive. You do not have a send, and you could have unknown messages where both the send and receive events are not present. So, that is the kind of default. But certainly in a diagram, in a sequence diagram, unknown message usually would not mean anything. You should not have. So, see here, if you see here the web client search message which was a lost. So, the lost message can be indicated by using a circle after the object. So, next coming to the, this is the how the lost messages are indicated. Next coming to the found messages. It is just like a found message is a message of which the caller is not shown. So, just like in old movies we used to see Akash Ramanavtralu, which doesn't contain any address. okay, who has sent that message. That are nothing but the found messages. Here also we'll receive the notifications. We are not going to concentrate where the notifications, from where we are getting these notifications. Okay, that is not important sometimes also. We need to know we got a mail, that's enough. We don't want where this message has got from to our mobile. So this is regarding the found messages. If you see the figure here, so found messages are indicated before the object by using a round circle, filled circle. So found message, and that will be received by the receiver, just like a mobile notifications. Okay, the exact sender is not known here, or it is not relevant to this interaction also. It is not mandatory to know who the sender is also. Depending on the context, this could mean that either the sender is not known, or that is not important who the sender was. So the arrow of the found message originates from the filled circle. Lost means later we'll get the filled circle. Found means before we get the filled circle. Okay, so this is regarding the lost message and the found message. Next, coming to the guard. A message can include a guard. Guard is nothing but a condition, which signifies that the message is only sent if a certain condition is met. If we met that condition, the message will be sent. So if you want to indicate such type, then you can go for the guard conditions. It's just like a if condition. If you met so and so, then print this statement. If you want to tell such type of conditions, then you can go for the guard. So the guard is simply that condition between brackets. So guards are used throughout the UML diagram to control flow. If you see here in the figure, sender and receiver. So from the sender we are having some condition, that is nothing but the guard statement. After that we are having some message with the parameters. When the condition is met, the message is sent to the receiver. So the message is only sent when the condition is met. So if you see here one of the example. So here we are having register office, and accounts receivable drama class. So what does this scenario is telling means get past balance. Here if the students want to attend for the drama class, then they need to clear the due balance of the previous semester. Okay, then only they can attend the drama class. If you want to specify such conditions, what is the condition here? The past balance should be 0. Then only they can attend the drama class. See here, now you will understand the figure what is showing. So register office, accounts receivable, drama class. So get past balance. Okay, we'll give the student ID, we'll send the what is the balance, what is the past balance to the account section. They will tell about the what is the past due balance. If the past due balance is 0, then his name will be added to the drama class. If there is any balance, then he can't attend the drama class. So if you want to show such a type of conditions, you can go for the guard statements. Next one is combined fragments. So fragment is nothing but a piece of part. Here we are having some combined fragments. We are combining those fragments. Here we may get alternatives, options and loops. Alternatives means if else conditions. If not this condition is matched, then we will go for the else condition. Options, what are the remaining options? Loops, if you want to iterate. So that all can be represented by using the modeling language. This is importance of this modeling language. Whatever you can implement in the programming language, same you can implement here also. So if you want to show such several messages are conditionally sent under the same guard, you will have to use an opt. Opt is nothing but a optional, options, combined fragment. The combined fragment is shown as a large rectangle. You can represent this combined fragments by using a large rectangle with an OPT that indicates options, operator plus and a guard also. What the condition? You need to specify that condition also, and contains all the condition messages under that guard. So if you see the figure here, we are having some sender, receiver 1 and receiver 2, and we are having some messages fragments, and they are shown in a rectangle, and we are having some OPT option and some guard condition. If the condition is met, then the messages are sent to all the receivers. So how that can be shown by using the UML diagram. So see here, we are having some registration officer, accounts receivable, drama class. So get the due balance of the student ID. We'll get the past due balance. Then what will happen? If the balance is equal to 0, then again we'll be having other questions. Okay, we'll add the student. So what is the present cost of this class? That will be sent if they'll charge if the student pays that amount, then he can attend the classes also. So if you want to show such type of options, okay, then you can use this options. Okay, if the student is not interested to go for the drama class, then he can go for the some other class. Or else if you don't have any amount, if you don't want to pay any amount, then he can go for the ground and he can play whatever he wants. If you want to show such type of options, then you can use this. Coming to the alternatives, ALT. If you want to show several alternative interactions, use an ALT, combined fragment. The combined fragment contains an operand for each alternative. Each alternative has a guard and contains the interaction that occurs when the condition for the guard is met. See here, if you see the figure here, it is having sender, receiver 1, receiver 2. And here we are having an ALT. It indicating that if the condition 1 is met, then the following interaction takes place. If the condition 2 is met, the second interaction takes place. If there are no satisfying conditions, then we go for the else part. Okay, this is regarding the alternatives, just like a switch condition. Okay, next coming to the example. Consider an example, bank. So here check and checking account. These are the three objects here. So if you see here, whenever we go to the bank, if someone gives us a check, so we'll go to the bank. If the here, see, first of all, before withdrawing the check, the cashier will check whether the balance is in the account is sufficient or not. So if the amount is not sufficient, then he will say that the amount is not sufficient. See here, if you see here, first of all, if the balance is available, he will give the amount. If the balance is greater than or equal to amount, means you can withdraw the amount, and that amount will be deducted from your account. So that status will be updated. Else what will happen? If the amount is insufficient, then same will be represented to the client and they will return the check back. Okay, if you want to show for some condition, if the amount is less than the balance in the account, then he can process. If the balance is less than the amount, then we need to return back the check. That's what here we mentioned by using this alternative. Next, coming to the repeated interactions. So repeated interactions means whatever we do by using do while, for loops. The same thing we can do by using this repeated interaction. When a message is prefixed with an asterisk. So asterisk means we used to represent by using a star symbol, which is used to represent the multiplicity. It means if you use the asterisk symbol, then the message can be sent repeatedly. A guard indicates the condition that determines whether or not the message should be sent again. As long as the condition holds, the message is repeated. If you see the figure here, it indicating that sender and receiver. And beside the condition, we are having a star symbol. As long as the condition holds, then the messages are sent. It means for I is equal to 1, I less than or equal to 10. Whenever the condition equals to 10, then the message sending will be stopped. Here also the same. And if you want to show the multiple messages are sent in the same interaction, it means you can send multiple messages to the multiple users also. A loop combined fragment can be used. The operator of the combined fragment is loop and the guard statement, the condition to control the repetition. See here, if you see the figure here, sender and a collection. Collection means multiple objects. So based on single condition, you can send a multiple message to the clients, other instances. Both messages are sent as long as the condition is met. This is regarding the iterations. Next, creation and destroying of messages. A create message represents the creation of an instance in an interaction. The target lifeline begins at the point of the create message. A destroy message represents the destruction of an instance in an interaction. The target lifeline ends at a point of the destroy message and is denoted by a cross symbol. Already we have seen in the sequence diagrams. When the object want to create another object for its purpose, then By sending a create stereotype, it can create the object. After the completion of the task, then it can send a destroy message so that the object which has been created has been destroyed. So its lifeline has been ended. That can be shown by using a cross symbol. So here let's see an example of sequence diagram for issuing a book. So here we are having the objects like a librarian, book, member record and transaction. So first of all, if you want to issue a book, then this is the purpose of the librarian. Librarian will do this thing. So whatever, first of all, he need to check whether the book is available in the library or not. If once the book is available, he can issue the book. Next thing he need to identify is whether the person is a member of the library or not. This is what he need to verify before issuing the book. So see here, he'll check whether the book is available or not. Once the book is available, that will be checked in the book database. So he'll validate the member, whether the member he is a valid member of this college or for this school or not. He'll verify it. He'll check the number of books issued. Sometimes faculty will issue the 5 books. For students, they will be only issuing of 2 books. So whether if he has taken the 2 books, then this book cannot be issued. So that also need to be verified. So if he has taken only 1 book, then this book can be issued. Based on this, the librarian will issue the book by creating the transaction. So once the book is issued, then the same details of book is updated in the book database, and the same thing is updated in the membership record also. So coming to the next topic, that is communication diagrams. A communication diagram emphasizes the organization of the objects that participate in an interaction. You form a communication diagram by first placing the objects that participate in the interaction as the vertices in a graph. Next, you render the links that connect the objects as the arcs of this graph. So similarly, as while discussing the building blocks of the UML, we thought that things and relationships, the interesting collection of things and relationships combinedly called as diagrams. Here also the things which are used in these diagrams are considered as the vertices, and the relationships connecting the things are nothing but the arcs. So the links may have role names to identify them. Finally, you add on these links with the messages that the objects send and receive. So you can use any stereotypes to represent the links like a create, destroy, send, local, global, parameter. All these are the adornments which you can use on the link, so that you can tell what the visibility of what the association with the other object. This gives the reader a clear visual cue to the flow of control in the context of the structural organization of objects that collaborate. The important thing which we have to note here is, unlike a sequence diagram, you don't show the lifeline of an object explicitly in the communication diagram. We already discussed that only lifelines are used in the sequence diagram. We can't use the lifelines in the communication diagram. Although you can show both create and destroy messages in the communication diagram, so that we can identify the transient objects in the, it means when transient objects are created between the execution. So that can be identified by indicating this create and destroy messages. In addition, you don't show the focus of control explicitly in a communication diagram, although the sequence number on each message can indicate nesting. So I told you that by using the procedural, we can indicate the nesting, and by using the flat sequence, we can represent the 1, 2, 3. Communication diagrams also have 2 features, whereas sequence diagrams having 2 features like a lifeline, and next one is a focus of control. Next, coming to the communication diagrams, these also having 2 features that distinguish from the sequence diagram. First, there is the path. You render a path corresponding to an association. You also render paths corresponding to local variables, parameters, global variables, self-access. A path represents a source of knowledge to an object. And coming to the second feature, there is a sequence number. To indicate the time order of message, you prefix the message with a number, starting with the message number with the 1, increasing monotonically for each new message in the flow of control as 2, 3, 4 and so on. To show nesting, you use deviate decimal numbering. 1 is the first message, which contains a sub-message. Then you can represent as a 1.1, 1.2 and so on. You can show nesting to an arbitrary depth. Note also that along the same link you can show many messages. And each will have a unique sequence number. This is regarding the two features of the collaboration diagram. First one is regarding the links and second one is the sequence number. Next, coming to the semantic equivalence. Because they both derive from the same information in the UML's meta model. Sequence diagrams and communication diagrams are semantically equivalent. So if you see the figure here, it is having actor, lifeline 1, lifeline 2 and lifeline 3. These are the different objects. So what is the communication taken place is represented by 1A, 1.1B, 1.2C. These are the subsequences. So for the same figure which we have represented in the same sequence diagram, for the same you can transform it into collaboration diagram. Collaboration diagram also consists of the same number of objects, but the sent message will be sent on the top of the link and the received message is shown in the down of the link. So this is how you can represent. In sequence diagram, you always no need to specify the sequence number, but while coming to collaboration diagram, it can convert the order of the message into sequence number so that it is easy for the user to identify which messages are passed first and which messages are passed second. As a result, you can take a diagram in one form and convert it into another without any loss of information. As you can see in the previous two figures, which are semantically equivalent. However, this does not mean that both diagrams will explicitly visualize the same information. For example, in the previous two figures, the communication diagram shows how the objects are linked. And note that local, global annotations. The corresponding sequence diagram does not show all these things. Similarly, the sequence diagram shows message written, but the corresponding communication diagram does not do that. In both cases, the two diagrams share the same underlying model, but each may render some things that the other does not. However, a model entered in one format may lack some of the information shown on the other format. So, although the underlying model can include both kinds of information, the two kinds of diagrams may lead to different models. Coming to the common modeling techniques of interaction diagrams. So we are having two interaction diagrams. First one is a sequence diagram, second one is a collaboration diagram. So based on the sequence diagram, which is used to show the time ordering of the messages, and based on the collaboration diagram, which represents the structural organization. So these two are the common modeling techniques of interaction diagrams. So let us see in detail. First, coming to the common modeling techniques, modeling flows of control by time ordering. So this is how we can draw a sequence diagram. That's what explaining in this modeling flow of control by time ordering. Consider the object that live in the context of a system, subsystem, operation or class. Consider also the objects and roles that participate in the use case or collaboration. To model a flow of control that wins through these objects and roles, you use an interaction diagram to emphasize the passing of messages as they unfold over time. You use a sequence diagram, a kind of interaction diagram. So, to model the flow of control by time ordering, let's see what the steps. So, first of all, set the context for the interaction, whether it is a system, subsystem, operation, class, or one scenario of a use case or collaboration. You need to identify the context. Set the stage for the interaction by identifying which objects play a role in the interaction. Lay them out on the sequence diagram from left to right, placing the more important objects to the left and neighboring objects to the right. So in the x-axis, you need to have the objects. So most important object should be on the left side. After that, which is communicating with this object, you need to place towards the right side. Next one is set the lifeline of each object. In most cases, objects will persist throughout the entire transaction. For these objects that are created and destroyed during the interaction, set their lifelines as appropriate and explicitly indicate their birth and death will approximately stereotype the message. By using a create stereotype, you can tell that the object is created. By using a destroy stereotype, you can say that the object is destroyed. Starting with the message that initiates this interaction, lay out each subsequent message from top to bottom between the lifelines. Show each message properties as necessary to explain the semantics of the interaction. If you need to visualize the nesting of messages or points in the time when actual computation is taking place, add on each object's lifeline with its focus of control. If you need to specify time or space constraint, add on each message with a timing mark and attach suitable time or space constraints. If you need to specify this flow of control more formally, attach pre and post conditions to each message. Okay, this is how you need to model a sequence diagram. First of all, you need to consider a scenario. What the scenario you want to model. So, what are the next condition is identify the objects. If you consider the figure here, it is having objects like a caller and another is also a caller. It is nothing but a sender and the receiver. Next, there is a switch between the objects. Here, the sender sends the message. He wants to make a call to the receiver. So, first of all, he lifts the receiver and he will hear some dial tone. After hearing, he will dial some digits. Based on this, it will create a conversation and from the conversation, it will send a ringtone to the receiver. That ringtone will be heard by the sender also, and after connection, they both can speak together. This is what the communication can be done by using the sequence diagram. So this is regarding modeling the time ordering of the message. So next, coming to the modeling flow of control by organization. So this can be done by using the collaboration diagrams. Consider the objects that live in the context of the system, subsystem, operation or class. Consider also the objects and roles that participate in a use case or collaboration. To model a flow of control that runs through the objects and roles, you use an interaction diagram. To show the passing of messages in the context of the structure, you use a communication diagram, a kind of interaction diagram. So coming to how to model the flow of control by organization. What are the steps you need to follow? These are similar to the sequence diagram steps only. First of all, you need to set the context for the interaction. As usual, what we have done in the sequence diagram, we are doing the same here also. Whether it is a system, subsystem, operation or class or one scenario of a use case or collaboration. Next, set the stage for the interaction by identifying which objects play a role in the interaction. Lay them out on the communication diagram as vertices in a graph. So here in the sequence diagram, we have taken a x-axis as the objects and y-axis as the lifeline. And here we need to consider as a graph. Here we need to consider objects as the vertices and we need to draw the links as the arcs. And placing the more important objects in, what is the more important object? That is placed on the left side in the sequence diagram. Here in the collaboration, the important object should be placed in the center. Okay, center of the diagram. And the neighboring objects around the center object. Specify the links among these objects along with the messages may pass. Lay out the association links first. These are the most important ones because they represent structural connections. Lay out other links next and add on them with the suitable path annotations to explicitly specify how these objects are related to one another. Starting with the message that initiates this interaction, attach each subsequent message to the appropriate link, setting its sequence number as appropriate. Show nesting by a D-weight decimal number. So if you want to show the procedural, you can show it. If you want to show flat, you can show it. So if you want to show the procedural means you need to follow the D-weight decimal numbering. If you need to specify time or a space constraint, add on each message with a timing mark and attach suitable time or space constraints. If you need to specify this flow of control more formally, attach the pre and post conditions to each message. This is how you can model the structural organization of the objects. Okay, so what are the main points you need to consider means in the sequence diagram you need to more concentrate on the objects with the lifelines and the focus of control. Coming to the collaboration diagrams, you need to concentrate more on the links and sequence number of the objects, of the messages. Okay, this is regarding the interaction diagrams. Next, coming to recap. Let's have a quick recap about the topics which we have discussed so far. In this unit 4, we have discussed about the basic behavioral diagrams, in which we have discussed about the interactions. In the interactions, we have seen about what is an interaction, what are the messages and the links, and how to use the stereotypes while using the links. And we have seen about the sequence diagram. In the sequence diagram, we have discussed about the lifeline and focus of the control. Coming to the collaboration diagram, we have discussed about the links and the sequence number. We came to know that sequence diagram and collaboration diagram are semantically equivalent and isomorphic. And we have seen the common modeling techniques of interactions. In the interactions, we have seen only one common modeling technique, that is to model the flow of control. Next, coming to the interaction diagrams. In the interaction diagrams, we have gone in detail about the sequence diagrams and the collaboration diagrams. Both are semantically equivalent and both are isomorphic, but they are not representing the same information. Okay, coming to the common modeling techniques of interaction diagrams, we have seen two common modeling techniques. To model the flow of control by time ordering, and second one is to model the flow of control by organization. So these are the two common modeling techniques we have discussed in the interaction diagrams. Next, we have seen about the use cases. And we came to know that use case is used to represent the scenarios or set of the sequences. And next, in the coming to the common modeling techniques of the use cases, these are used to represent the behavior of the elements. And next, we have seen about the use case diagrams. In the use case diagrams, we have discussed about the relationships such as generalization, extend, and include. And coming to the common modeling techniques of use case diagrams, we have discussed about the modeling the requirements of a system, and next is modeling the context of a system. And coming to the last interaction diagram which we have discussed in this basic behavioral modeling is activity diagram. So here we have seen about what is an activity, what are the activity states, and we have seen about the swim lanes, and these are the different topics which are new to us. We have discussed all these things. And coming to the common modeling techniques of activity diagrams, we have discussed about how to model the time constraints and how to model the distribution of objects. That's what we have seen in this basic behavioral modeling. And this is regarding a quick recap regarding the unit 4. Next, coming to the important topic, that is interesting one also, that is quiz. And by seeing this quiz questions, you will understand how you are clear about the topics. So let me start the quiz. First question. Dash are used to model the dynamic aspects of collaboration. Coming to the options, sequence diagram, and structural, interactions, D messages. So the answer is interactions. Coming to the second question, interaction diagrams are of dash types. So options are 1, 2, 3 and 4. So interaction diagrams exist in two forms. One is a sequence diagram, second one is a collaboration. Dash diagrams permit you to model the lifetime of an object. So if you want to tell about the lifetime of an object, which diagram is used? So sequence diagram, collaboration, state chart, activity. So we know that lifetime can be represented by using the lifeline of an object. That can be represented in the sequence diagram. And dash shows an interaction consists of a set of objects and their relationships including messages. So options are interaction, class, use case, activity. So it is telling about the interaction, objects and their relationships, that is none other than interaction diagrams. Next question. The behavior of a system is modeled using class diagram, activity diagram, use case diagram, interaction diagram. This can be done by using the use case diagram. That's what we have seen in the while telling about the architecture of the UML also. We have seen about the 5 views. In that, one of the view is use case view. In that, it tells about the behavior of the system. In an activity diagram, organizing the activities into groups is called options: forking, joining, swim lanes, synchronization. Option C, swim lane. Dash is used to represent concurrent flows in an activity diagram. The options are slide bar, synchronization bar, swim lane, branch. The answer is synchronization bar. Coming to the next question. Executable atomic computations are called A. Action states, activity states, composite states, concurrent states. The answer is action states. Activity diagram is a special kind of dash. Use case diagram, state chart diagram, interaction diagram, component diagram. The answer is state chart diagram. Which of the following diagram view the whole system as a block box? So, class diagram, activity diagram, use case diagram, interaction diagram. So, block box, that is nothing but use case diagram. Actors are connected to the use cases only by association relationship, generalization, realization, dependency. We have already discussed this, that is association. Forward engineering is the process of translating dash options model to model, code to model, model to code, code to code. That is model to code. Dash relationship between use cases means the base use case explicitly incorporates the behavior of another use case at a location specified in the base. The options are exclude, extend, include, abstract. The answer is include. So these are the few questions which we have covered in the basic behavioral modeling, and if you can answer these questions, you understood the class well. If you have any doubts, go back and play the video. Okay, if you think that I am going a little bit fast, then play the video slowly. Hope you people know about it. If you don't have any idea, just go to the settings symbol on the video, click on playback speed, then customize the speed according to your need. Thank you so much. Let's meet in the next session with the Unit 5. Till then, have a safe day. Follow SMS. SMS means sanitizers, masks and social distancing. Stay safe, stay healthy. Thank you.